Alright, so this is a tips and tricks video that's going to cover a couple of things. One thing this video is going to cover is just the different types of plasticware we have in the lab. And the other thing that's going to be covered in this video is pipetting. So many of you who have been in a lab before may already know all of this. This can be used as a review, or you can skip this one if you want. But a lot of people who are new to molecular biology haven't done a lot of pipetting before, and I think this video might be helpful. So first I'm going to cover a lot of the plasticware that will be in the molecular biology focused videos or planarian videos that will follow. One is we'll use some petri dishes. We have 3 different kinds that we often use. The smaller one is a 60 millimeter petri dish. And then we have 2 types of 100 millimeter or 10 centimeter dishes. One of them is a deep dish and one of them is shallow. So those are the 3 kinds of petri dishes that we'll commonly use in the lab. We use several different types of tubes. The larger tubes that we are going to use are called conical tubes. And you'll see us use 2 different conical volumes. This is a 50 milliliter conical tube, and this one is a 15 milliliter conical tube. I've shown you 2 different kinds. We'll sometimes have different brands in the lab, so some may have orange or blue or yellow lids, but that's what those will be. When we do bacterial work, we'll also use a 3rd type of large tube called a culture tube, and these have a slightly different kind of plastic, and that's the only thing you'll use these tubes for, is growing bacteria. We also have 2 smaller types of tubes that we'll often use. This type of tube is called a 1.5 milliliter tube. So you can see there it fits 1.5 milliliter. And the smallest tube that you'll commonly use are these PCR tubes, which will be used for small reactions like setting up PCRs. Okay, so those are the main plasticwares that we'll use, and in a moment we'll come back and start with pipetting. Okay, so whenever you're pipetting, what you're going to be doing is measuring and moving specific volumes of liquid. And the first set of pipetting that we'll do are pipetting volumes between 1 milliliter and 50 milliliters. And to do this, you're going to use a pipetter. This is a stripetter, and you're going to use pipettes that look like this. So there are 4 different kinds. There's a 50 milliliter one, a 25 milliliter one, a 10 milliliter one, and a 5 milliliter one. And these are all in a wrapper that keeps them sterile. And so if you look in the sides of these tubes, you can see different gradations. So this is the 5 milliliter tube. And if you are on one side of it, it will have a 0, and then a 1, 2, 3, 4, and then 5 would be to the end. If you look on the other side, it will count in the opposite direction. So on the other side, it would be 1, 2, 3, 4, 5. And you'll also see that this is the 5 milliliter mark. There's also room to do 1, 2.5 more milliliters. So the maximum capacity of one of these pipettes doesn't exactly match the number. So you can fit 7.5 microliters in the 5 milliliter one. I think maybe 13 milliliters will fit in the 10. 32 milliliters will fit in the 25, and I think 60 milliliters will fit in the 50. So in the protocols you use, if you ever have to measure out a volume of liquid that's in this range, you can use these pipetters. And I'm going to just pipette some water around for these videos. So in this instance, if you have a sterile bottle, you always want to make sure you don't just leave the lid off. You're just going to maybe loosen it and then pipette right when you're ready. So say I wanted to measure out 3 milliliters of water. I would unwrap the end, starting with the cotton end of my 5 milliliter pipette. I would firmly, but not, not breaking it, but firmly push it into the pipetter, and then slide out the pipette from there. Because this is sterile, the pipette can be considered sterile unless you touch something. So if you pull it out and then you touch the tip of this pipette with your hand or to the bench, it's not sterile anymore and you need to get a new one. If I wanted to measure out 3 milliliters, I'm either gonna, depending on which side, this side would be 1, 2, 3. The side toward me says 4, 3, 2. So I'm going to carefully pipette up to that volume, 3 milliliters. I'm going to cap the bottle right away so that it stays sterile. And then if I wanted to pipette it into one of these tubes, I would do so. So what I didn't show you, or you couldn't see, is that these two buttons are what allow you to pipette. So the top button will allow you to pipette up. The bottom button will allow you to pipette out. And you can change the speed on the top of your pipette. So we're done with that one. But on the top you can change the speed and the mode. And you can play around with this sometime when you're not really doing things for real, so that you understand what the speed will look like. So if you were trying to pipette quickly, you might want to have high speed or low. Also, these pipettes are also kind of sensitive to touch, so sometimes you can pipette just a little, you know, in little bursts or with a gentle touch and get a different rate. If you wanted to pipette a larger volume, you would then use a larger pipette. I think a good rule of thumb is whatever your volume is, you want to use the smallest pipette that can fit that volume. So in the previous example, I said we were going to pipette 3 milliliters. You don't want to use a 50 milliliter pipette for 3 milliliters. You want to use the 5 because it's closer to that volume. It will be more accurate than using a larger pipette to pipette a smaller volume. So if you needed to pipette, you know, 8 milliliters, that does not fit in the 5 milliliters, so you have to use the 10. If you needed to pipette 20, you'd have to use the 25 milliliter pipette. Or if you needed to pipette 40 milliliters, you'd use the 50 milliliter pipette. The speeds will be a little bit different, so now I'm going to pipette this 20 milliliters if I have enough in here. And while I'm pipetting, I have the 20 in my sight, so I'm making sure that the liquid line is right at 20. I'm keeping it sterile, and then I would pipette it into whatever container I needed to pipette it. Some solutions that you're going to pipette in the lab are very viscous, and the detergents will be like this. If you notice that when you pipette out, a lot of the material still sticks in the pipette, then you might consider a different way of measuring that liquid by pouring or something like that. So when I make detergent solutions, I usually pour things out. Used pipettes can be either just discarded like this, or you can put them back in the sleeves. And we have some plasticware boxes around the lab to dispose of these pipettes. Please don't put these in the trash because they have a little bit of a point at the end. They can tear the trash bag and either poke the custodians as they're taking out our trash, or they can tear the bags and cause a big mess. So just make sure, you know, I kind of keep them on my bench as I use them, and then periodically put them in the trash. So that is your pipetter. If you ever have a pipetter that stops working, it probably just needs to be charged by plugging it in. The other thing that can happen is, what if you aren't paying enough attention and you suck up liquid past the point it should be? And the first thing that will happen is if you just get it up a little bit too far, it will go into this cotton ball, and that will kind of protect you from a problem. There's also a filter that's in the top of the pipetter. Let's see if I can... There's a filter in here that keeps the liquid from going all the way up into the pipetter, although you can get liquid in this and ruin it if you are really not paying attention. So if you ever have an experience of you thinking that you might have pipetted your liquid into the pipette, please find one of us so we can at least replace this filter. And you want to be careful not to do that. These, you know, every time we replace one of these, that costs money and should be avoided if you're paying attention. Okay. Next, we're going to talk about pipetting volumes under 1 milliliter, and I'm going to take just a pause, and then we'll be right back. Okay, so the pipette that we just talked about can be used for volumes over 1 milliliter and up to 50 or even a little bit above 50 milliliters. If I'm wanting to be really accurate, I can even do 200 or 300 milliliters by using the 50 ml pipette over and over again. But under 1 milliliter, we're going to use a set of micropipettes. And so at most of the benches in the lab, there will be 4 of these. So the largest one will have a blue top. This is a P1000. The next biggest will be your P200. The next biggest will be the P20, which has this kind of like off-white lid. And then the smallest will be a P10. There's also a few P2s lying around. And what that P number will indicate is the maximum volume in microliters. So microliters are, 1 microliter is 1,000th of a milliliter. And if you have a P10, for example, it will fit, it can be used to pipette up to 10 microliters. So you have a set of these because you may have different amounts that you need to pipette. The other thing that I'll mention is that these pipetters should be used with tips. So there are different tips. So there are large tips for your P1000. There are, middle-sized tips that are usually in a green box that will fit your P200. And then there are smaller tips that will fit the P10. Okay. And those middle-sized tips, I said they will fit the P200. They'll also fit the P20. We also have a set of filter tips in the lab, and these are a little bit different. We use these for RNA work, so when you're making double-stranded RNA, riboprobes are working with those RNA solutions. And these tips are a little bit different. They're still the same difference in size, so these would be the P1000. And you'll see that they have a little bit of a filter, and that keeps a couple things from happening. That keeps, if you were dealing with something really caustic, that solution from getting on your pipette. If you're working with RNA, it also keeps RNases that might be on your pipette out of your sample. So in addition to those big P1000 filter tips, we have a couple of other sizes. There are these teal with white tips that can be used for the P200. There are these teal with yellow tips that can be used for the P20. And there are these kind of orange and navy blue filter tips that can be used for the P10. So those are a little more expensive, and I would ask that you not use those for everything, just for RNA work. I will mention that these are the tips that we have currently in the lab. If you end up watching this video down the road, we may have changed our tubes or tips. You should still be able to find these materials, although the brands or the colors or stuff like that might change. Okay, so in a protocol, you may be called upon to pipette a specific volume of liquid. And the first thing you have to think of is which micropipette is most fitting for that job. So if you were asked to pipette 800 microliters, for example, that would best fit in the P1000. It's greater than 200, so it would not be pipettable with the P200. As I mentioned with the regular pipette and the long pipettes, you want to use the micropipetter that is the smallest. So for example, if you were pipetting 3 microliters, you don't want to use the P1000, you'd want to use the P10. The smaller micropipette will be more accurate for small volumes than the large pipette would be. So going back to our example, so 800 microliters, we would look at our P1000, and then we would look here to the side to see what volume we needed to pipette. So for the P1000, the red digit is the thousandth, so if you had 100, that would be 1,000 microliters or 1 milliliter. Here, it just happened that I had already set it to the volume I need, so 080 would be 800 microliters. So once you've set your pipetter, and you can use this knob to change the numbers so that it matches the volume you need. So if you needed 795, you would do 795 9 and then halfway between 9 and 0. But for 800, again, we do 0, 8, 0. So then you want to put your pipette tip onto your pipette. Once the pipette tip is onto this, it's sterile, so you don't want to touch it to anything. So if this touches your bench or your hand, or you graze it against something, you want to discard it and start again. You will then have your liquid that you're trying to pipette. I try usually not to pipette out of big bottles, although sometimes you have to. You're going to put your pipette into the liquid and have it go below the surface. You don't want to shove this all the way in because you don't want the pipette to be wet outside of the tip. So before you put it in to the volume or to the tube, you're going to depress this to the first stop. Okay, so if you have one of these pipettes and you're just playing with it, you can feel it stop, and then it can go past that stop. So before you put your tip into the liquid, and I've kept it sterile this whole time, don't worry, you're going to depress it to the first stop if you're trying to pipette up. Then you're going to put the tip into the liquid and then release the button, and that will allow you to suck up 800 microliters. When you're ready to pipette this liquid into another tube, you are going to put that tip into the tube you're pipetting into, and then press down to the first stop, and then press all the way down to make sure you've gotten all of that liquid out. So if you've never used micropipettes before, I would recommend just pipetting a water around like this for a little while. You can just get some tubes and water out of the sink to get familiar with what these pipettes feel like. So first stop, if you're going to pipette something up, you go to the first stop, put your tip into the liquid. Then if you want to suck up that liquid, you're going to let it go to your next tube, press down to the first stop, and then the second stop. The other thing you can do is eject your pipette tip once it's been used. And there's another button here, and if you press it down, you'll eject your tip. It's like connected to this ejector. These tips, like the pipettes, can puncture the trash bags. So I usually keep a little tri-cornered cup on my bench to shoot my pipette tips into, and then I can discard them in the plastic waste as well. So that was the P1000. Next, let's look at the P200. So for example, we could use the P200 to pipette 150 microliters if we wanted to. So if I look at this, all of the digits on the P200 are black in color, and they are the hundredths digit, the tenths, and the ones. So if this said 100, that would be 100 on the P200, whereas it was 1000 on the P1000. And I think one way I think about it is the red digits are the thousandth place and the 0.1 place when you get down to the P10. And the black colored numbers are the hundredths, tenths, and single digits. So if I wanted 150, what that would look like on the P200 is 150. Again, I'm just moving this knob to until my pipette reads 150. You use a different tip for these pipettes, so make sure you're keeping that straight. And then I would depress the button, put my tip into the liquid, release the button. So now I have the right amount. Make sure you don't have bubbles in there or anything like that. I would go into my next tube, I would depress the button to release, and I would go past that first stop down to the bottom to make sure all of the liquid gets ejected. One thing I should note is that once you press the button all the way out and you've released your liquid, you don't want to let that button go while you still have your tip in the liquid, or you'll suck volume back up. So you want to keep your button held down, pull the tip out of the liquid into which you're pipetting, and then release the button. And that way you don't suck up the stuff that you need to. When you're first learning how to pipette, one good thing to do is to really pay attention to the volumes on your tubes. So if you're pipetting into a 1.5 ml tube, you'll see that it has some gradations on it, the same as with the other tubes. So whatever you're pipetting, you can try to use those gradations to make sure that you know your final volume is in the ballpark that you wanted. What are some mistakes that people commonly make? One is that you use the wrong pipette. So if you had the P1000 and you set it to 100, thinking you were going to do 100 microliters, you'd actually do 1000 microliters. So you have to consider both which pipette you have and how it's set when you're determining how much to pipette. So that's one thing that people often have trouble with. If you misunderstand what the numbers are or what they mean, that could be another one. Misusing the buttons. So if you go all the way down to the full stop and then suck up a liquid, your volumes will not be accurate. So that's why you want to go down to the first stop, pipette up, and then go to your second tube, go to the first stop, and then go all the way down. What are some other things? You could use the wrong tips. That would be a problem. They probably would not fit, and then you would therefore not have accurate pipetting, and so on. So I showed you the P1000 and the P200. The other two pipettes are the P20 and the P10. Both of these, as you'll see, have 2 digits that are black in color, and then the third digit is red in color. And that red digit would be the after the decimal place. So this, where it says 100 is set at 10 microliters. This that says 200 is set at 20 microliters. So I think before I would pipette very much, if you haven't done this before, I would just get myself really familiar with these pipettes. You can always use the scale to make sure you're pipetting accurately. So 1 milliliter of water is 1 gram. So you can always kind of make sure, pipette onto like a weigh boat or something and make sure your pipetting is accurate. And just practice this for a little while until you feel really comfortable, because a lot of the protocols we use are going to rely on either the pipettes or the micro pipettes. And if you don't feel really comfortable with those, you can cause errors that will make your experiments not work. I just wanted to add one more thing about the micro pipetter tips, both the regular tips and also the RNA-free or filter tips. You want to make sure that you leave these boxes closed on your bench. They're sterile, and so they don't have microbes or other dust or material in them, so long as they're kept closed all the time. So of course you have to open these boxes to get your pipette tips, but you want to leave them closed on your bench. If you've left your box of tips just sitting open for a long time, they're probably not sterile anymore and you may need to discard them, which just ends up being really wasteful. So as you're learning to pipette, you also want to be careful to remember to take care of your tips so that they'll be just as sterile and in good shape the next time you use them.